All right, good morning, good afternoon, good evening, good night, depending on when you're watching this video. In this video, we're going to work through the exercise given on slide 35 of lecture set 9. So this is not a mathematical exercise, it's an identification exercise. In lecture set number 9, we discussed two different types of two sample tests. We have the independent two sample test and we have the dependent two sample test. So in order to select the correct test, we have to be able to determine if the problem is presenting us with independent samples or dependent samples. So I have three exercises here, and all we're trying to do is determine if it's an independent, two independent samples or two dependent samples, and then give a little explanation as to why. All right, so identify if the independent two sample procedure or dependent two sample procedure should be used for each of the following problems. Explain your answer. A randomly selected sample of 50 people weigh themselves in the morning and in the evening. If they want to determine if there is statistical evidence that their average morning weight is less than their average evening weight, which procedure should they use? Okay, so the key here is that we have a randomly selected sample of 50 people, and they weigh themselves in morning and evening. So the same 50 people are weighing themselves in the morning and the evening. So each person is contributing two measurements. So this is going to be a paired structure. Then it says, is there evidence? So evidence, average morning weight less than average evening weight. So we want to compare the average morning weight of these 50 people to the average evening weight of these 50 people. So each person is contributing two measurements. So here we are going to use a dependent two sample procedure because the morning and evening weights are collected for the same 50 people. This creates a paired structure. Okay. So once we have identified that we have this paired structure, which means that each observation is contributing two measurements and we're comparing those two measurements, that means that we have a dependence, right? So the evening weights are related to the morning weights because they're taken on the same person. So this is an example where we would need a dependent t-test. Okay, part B. A collection of 40 first-year students and a collection of 55 second-year students compete in a 5-mile run. If they want to determine which year of students has the lower average time to complete the run, what procedure should they use? Okay, so this is going to be an independent two sample procedure because we have two different collections of people, right? The problem says we have a collection of 40 first-year students and a collection of 55 second-year students. We want to compare their average 5-mile run time. Okay, so we want to determine which year of students has lower average time. So we're comparing a group of 40 people to a group of 55 people. One of the keys here, as you can tell just by the sample size, is that this can't be paired because we have different numbers in each group. But the second year students is a different group than the first year students. So we're comparing a group of first years to a completely independent group of second years. So hence this is an independent two sample procedure because we have two unrelated populations of interest. I guess I could have fit that here, right? All right. And then in part C, it says, I want to compare the average midterm marks from 2 of my Stat 151 sections to see if a difference exists. Which procedure should be used? Okay, so 2 sections means, for example, I want to compare my class on Tuesday to a completely different class on Thursday. So this is the same argument as for part B. I have a collection of students that take Stats 151 with me on this day and a completely different collection of students that take Stat 151 with me on another day. So these are independent samples. So we would use an independent 2-sample test for the exact same reason that I gave in part B, right? So once we've identified the structure and whether or not that independence or dependence exists between the populations, we now know which procedure we should use. As always, if you have any questions, please let me know.